Tier 1. Chernobyl Disaster, 1986, USSR. The Chernobyl disaster remains the worst nuclear accident in history, turning a routine safety test into an absolute nightmare. What infuriates me is how preventable this whole mess was from the start. On April 26, 1986, Reactor 4 at the Chernobyl nuclear power plant in Ukraine exploded during what was supposed to be a simple experiment to test emergency power systems. The reactor's design had serious flaws, and the operators made several critical mistakes that night, including disabling safety systems and ignoring warning signs. When the reactor went supercritical, it literally blew the roof off the building, sending radioactive debris flying into the sky. The explosion and subsequent fires released massive amounts of radiation across Europe. The Soviet government initially tried to cover it up, but when radiation detectors in Sweden started going crazy, the secret was out. The immediate response was chaotic and heroic in equal measure. Firefighters rushed to battle the blazes without knowing they were walking into lethal radiation. Plant workers and volunteers, later called liquidators, worked desperately to contain the disaster, many sacrificing their health and lives. The nearby city of Pripyat was evacuated, and a 30-kilometer exclusion zone was established that remains largely empty today. The disaster scattered radioactive material across vast areas, contaminated farmland for decades, and created a lasting symbol of nuclear power's potential for catastrophe. Estimates of long-term deaths vary widely, from thousands to hundreds of thousands, making it as much a human tragedy as a technical failure. If you think that was bad, wait until you hear about this nightmare. Fukushima Daiichi Meltdown, 2011, Japan. Japan's Fukushima disaster proved that even the most technologically advanced nations aren't immune to nuclear catastrophe. On March 11, 2011, a massive 9.0 earthquake struck off Japan's coast, triggering a tsunami that would forever change how the world thinks about nuclear safety. The earthquake itself didn't doom the Fukushima Daiichi plant. The reactors automatically shut down as designed. But the tsunami waves, some reaching 40 feet high, overwhelmed the seawalls and flooded the facility. The real killer was the loss of electrical power. With backup generators flooded and batteries dying, the plant couldn't cool its reactors. Over the next few days, 3 reactors experienced meltdowns as temperatures soared beyond control. Hydrogen gas built up and exploded, blowing up apart reactor buildings in spectacular fashion, broadcast live on television to a horrified world. Unlike Chernobyl's single explosive moment, Fukushima was a slow-motion disaster that unfolded over days. Workers desperately pumped seawater into the reactors, knowing it would destroy them, but hoping to prevent complete meltdown. The Fukushima 50, actually closer to 70 workers, became international heroes for their willingness to stay behind and face near-certain death. The accident forced the evacuation of 160,000 people and contaminated huge areas of farmland and ocean. While direct radiation deaths were limited, the stress of evacuation and displacement killed more than 1,000 people. The disaster effectively ended Japan's nuclear expansion and sparked a global reevaluation of nuclear safety, particularly regarding natural disasters. Just when you think nuclear authorities couldn't be more reckless, along comes this story. 3 Mile Island Incident, 1979, USA. 3 Mile Island became America's wake-up call about nuclear power, transforming public opinion almost overnight. On March 28, 1979, what started as a minor equipment failure at the Pennsylvania plant spiraled into the nation's worst nuclear accident. A stuck valve led to a loss of coolant, but confusing instrument readings made operators think they had too much water, not too little. So they actually made things worse by reducing the water flow when they should have increased it. Media coverage turned the incident into a national crisis. The fact that the movie, The China Syndrome, about a nuclear meltdown had been released just weeks earlier seemed like an eerie coincidence. Pregnant women and young children were evacuated from the area as fears of radiation release spread. Governor Dick Thornburg's cautious public statements only heightened anxiety. While the actual radiation release was minimal and no one died directly from the accident, 3 Mile Island changed everything. Construction of new nuclear plants ground to a halt, and the incident exposed serious flaws in operator training and emergency procedures. The nuclear industry's promises of safe, clean energy suddenly seemed hollow to millions of Americans who had trusted atomic power. Moving from bad to worse, let's examine another case of atomic incompetence. SL-1 reactor explosion, 1961, USA. The SL-1 accident stands apart as nuclear power's most intimate tragedy, a small experimental reactor that killed 3 young men in an instant and baffled investigators for decades. On January 3, 1961, at a remote site in Idaho, Army specialists John Burns, Richard McKinley, and Richard Legg were performing routine maintenance on the stationary low-power reactor number 1. What happened next remained a mystery for years. The reactor was designed to be simple, so simple that it could be operated by soldiers with minimal training at remote military bases. But this simplicity came with a deadly flaw. The reactor could be made critical by manually pulling out just one control rod. For reasons that remain unclear, someone yanked a control rod out much too far and too fast, causing the reactor to go supercritical in milliseconds. The explosion was swift and terrible. The reactor vessel jumped several feet in the air, and one of the control rods shot upward like a spear, pinning one victim to the ceiling. All 3 men died instantly, the only direct fatalities from a reactor accident in US history. The reactor building became so radioactive that recovery crews could only work for minutes at a time. The investigation uncovered a web of poor training, inadequate procedures, and possibly personal conflicts among the crew. Some speculated about murder-suicide, though this was never proven. The accident led to major changes in reactor design and highlighted the dangers of small, simple reactors that seemed deceptively safe. The victims were buried in lead-lined coffins, their bodies too contaminated for normal burial. Up next, things get even more unsettling. If you're finding this content valuable, consider subscribing. It really makes a difference. Tier 2. Tokai-Mura Criticality Accident, 1999, Japan. The Tokai-Mura accident showed how deadly corners cut in nuclear fuel processing could be. On September 30th, 1999, at a uranium processing facility in Japan, workers were rushing to meet a deadline and decided to take a dangerous shortcut. Instead of following proper procedures, they mixed uranium solution in stainless steel buckets, completely bypassing safety systems designed to prevent exactly what happened next. Lives were put at risk because safety protocols were seen as optional, and that should never be acceptable in any industry, let alone one with such high stakes. Hisashi Ouchi, Masato Shinohara, and Yutaka Yokokawa were preparing fuel for an experimental reactor when they poured way too much enriched uranium into a precipitation tank. The moment the solution reached critical mass, an intense blue flash filled the room as neutrons began flying everywhere. The 3 men had just triggered Japan's first criticality accident, and 2 of them received doses of radiation that should have killed them instantly. The accident turned into a medical nightmare that shocked the world. Ouchi absorbed 17 sieverts of radiation, enough to kill several people, yet somehow remained conscious. For 83 agonizing days, doctors kept him alive using every medical technique available, even as his body literally fell apart at the cellular level. His white blood cell count dropped to 0, his skin started separating from his body, and his organs began failing one by one. The local community lived in terror as radiation spread beyond the facility. Hundreds of residents were evacuated, and schools closed for weeks. The accident exposed serious flaws in Japan's nuclear oversight and showed how easily safety procedures could be ignored when companies prioritized speed over safety. 2 workers died, and the images of their suffering became a powerful reminder of radiation's invisible horror. Wind-scale fire, 1957, UK. Britain's wind-scale fire became the country's worst nuclear accident, though the government spent decades trying to downplay its significance. On October 10, 1957, reactor pile number 1 at the Windscale facility in Cumbria caught fire during a routine maintenance procedure that went horribly wrong. The reactor was one of 2 built to produce plutonium for Britain's nuclear weapons program, and its primitive design made it a disaster waiting to happen. The trouble started when operators tried to release energy that had built up in the reactor's graphite core, a process called Wigner release. But they had botched the procedure, and temperatures began climbing out of control. By the time anyone realized what was happening, the graphite blocks inside the reactor were burning like a massive coal fire, spewing radioactive smoke into the countryside. For 2 days, the fire raged while officials debated what to do. The reactor had no proper containment, so radiation poured straight out of the 400-foot chimney stack. Finally, in an act of desperation, they decided to flood the burning reactor with water, a move that could have caused a massive steam explosion. Miraculously, the gamble worked and the fire was extinguished. Arguably, the greater wrongdoing wasn't the accident itself, but the decades of cover-ups and misinformation that followed. The government immediately clamped down on information about the accident. Milk from local farms was quietly dumped for weeks, and the true extent of the radiation release wasn't revealed for decades. An estimated 240 cancer deaths resulted from the accident, though officials initially claimed no one was harmed. The reactor building still stands today, a concrete tomb housing the radioactive remains of Britain's nuclear ambitions gone wrong. The next incident serves as a clear example of how far governments may go to conceal the truth. Kishtim Disaster, 1957, USSR. The Kishtim disaster was the Soviet Union's nuclear nightmare that the world didn't learn about for decades. On September 29, 1957, a massive explosion rocked the Mayak nuclear facility in the Ural Mountains, but unlike Chernobyl, this accident was buried under layers of Soviet secrecy. The facility was producing plutonium for nuclear weapons, and safety was an afterthought in the rush to match America's atomic arsenal. The explosion happened in a high-level radioactive waste storage tank when its cooling systems failed. Without proper cooling, the waste heated up until it literally exploded, launching the 160-ton concrete lid into the air and releasing a radioactive cloud that drifted across the countryside. The blast was so powerful that it scattered contamination over 800 square miles, creating what became known as the East Urals radioactive trace. The Soviet response was swift and brutal. Entire villages were evacuated overnight, and residents were told they had 2 hours to pack their belongings. More than 10,000 people were relocated, often to equally contaminated areas. Hundreds of square miles of farmland became uninhabitable, and the military cordoned off the most contaminated zones. But officially, none of this ever happened. For over 20 years, the disaster remained one of the Cold War's best-kept secrets. Western intelligence agencies suspected something had occurred when they noticed gaps in the Soviet scientific publications and missing researchers, but the full truth only emerged in the 1980s. The area around Mayak remains heavily contaminated today, with cancer rates still elevated among survivors. The disaster showed that the Soviet nuclear program's reckless pursuit of weapons came at a terrible human cost. Meanwhile, on the other side of the world, an even more disturbing event occurs. Goiânia Accident, 1987, Brazil. The Goiânia accident became one of the most disturbing examples of how radioactive materials could terrorize an unsuspecting population. In September 1987, two scrap metal dealers in Goiânia, Brazil broke into an abandoned medical clinic and stole what they thought was valuable equipment. Instead, they had stolen a cesium-137 radiotherapy machine containing enough radioactive material to contaminate an entire city. Roberto dos Santos Alves and Wagner Mota Pereira had no idea what they'd taken. They brought the device to a junkyard where Diver Ferreira tried to dismantle it with a sledgehammer and screwdriver. When they finally cracked open the lead casing, they found a glowing blue powder that seemed magical. The cesium chloride crystals glowed in the dark like something from a fairy tale, and soon everyone wanted to see the mysterious substance. What followed was like a nightmare from a horror movie. Ferreira gave chunks of the material to friends and family members who smeared the pretty blue powder on their skin like body paint. Children played with it, and one 4-year-old girl, Leigi dos Neves Ferreira, ate some of the glowing powder while sitting on her father's lap. Within days, people began falling violently ill with radiation sickness. By the time authorities realized what was happening, the contamination had spread throughout the city. More than 100,000 people had to be monitored for radiation exposure, and 249 were found to be contaminated. 4 people died, including little Leigi, who became the accident's most tragic victim. The incident exposed dangerous gaps in radioactive material security and showed how quickly nuclear materials could spread terror through an unprepared population. You still here? Appreciate you sticking around. If you're finding this interesting, a quick like on the video really helps out. Santa Susana Field Laboratory Leak, 1959, USA. The Santa Susana accident was America's hidden nuclear disaster, a meltdown that happened just 30 miles from Los Angeles but remained secret for decades. On July 13, 1959, reactor SRE, sodium reactor experiment, at the Santa Susana Field Laboratory suffered a partial meltdown that released radioactive gases into the San Fernando Valley. Unlike other nuclear accidents that made headlines, this one was quietly covered up by the government and the company running the facility. The reactor was experimental, using liquid sodium as a coolant instead of water. When fuel elements began overheating and melting, radioactive gases built up inside the reactor vessel. Instead of containing the contamination, Operators made a fateful decision. They vented the radioactive gases directly into the atmosphere for weeks, letting the wind carry the contamination over suburban neighborhoods where families lived, worked, and raised their children. The accident should have been front-page news, but it wasn't. The Atomic Energy Commission at the facility's operator, Atomics International, managed to keep it quiet. Local residents had no idea they were being exposed to radiation as they went about their daily lives. Children played in their yards, families had barbecues, and life continued normally while invisible contamination settled on their homes and schools. Moments like this make you question how often the national image is placed above the well-being of people. The truth only began emerging in the 1980s when investigative reporters and concerned scientists started asking questions. Studies suggested elevated cancer rates in the area, and activists fought for decades to get the site cleaned up. The Santa Susana accident became a symbol of government secrecy and corporate cover-ups, showing how nuclear accidents could be hidden from the very people most at risk from their consequences. This next case offers another example of how safety can be compromised in the interests of military and industrial objectives. Church Rock Uranium Mill Spill, 1979, USA. The Church Rock spill became the largest radioactive disaster in U.S. history, yet most Americans have never heard of it. On July 16, 1979, just months after 3 Mile Island made headlines, a dam at United Nuclear Corporation's uranium mill in New Mexico burst, releasing 94 million gallons of radioactive waste into the Puerco River. The spill was actually larger than 3 Mile Island in terms of radioactive material released, but it happened on Navajo land, far from major cities and news cameras. The earthen dam had been showing signs of stress for weeks, with small seepages that company officials chose to ignore. When it finally failed, a 6-foot-high wave of contaminated water and sludge poured into the normally dry arroyo, carrying uranium, radium, and other toxic metals downstream. The radioactive flood flowed for 80 miles through Arizona and into Utah, contaminating everything in its path. For the Navajo people living along the river, the disaster was devastating. Families who had lived off the land for generations suddenly found their water sources poisoned. Livestock that drank from contaminated pools sickened and died. Traditional medicines gathered from the area became dangerous to use. Many Navajo residents weren't even warned about the contamination for days after the spill occurred. The cleanup was slow and inadequate. The company and government agencies spent years arguing over responsibility while contamination remained in the environment. Unlike other nuclear accidents that prompted major policy changes, Church Rock was largely ignored by mainstream media and politicians. The accident highlighted how environmental racism allowed disasters in minority communities to be overlooked, while similar incidents in predominantly white areas received massive attention and resources. The next incident proves that nuclear accidents are a global phenomenon. Vandalos Nuclear Plant Fire, 1989, Spain. The Vandalos fire showed how quickly a nuclear plant could spiral from routine operation to the edge of catastrophe. On October 19, 1989, Unit 1 at the Vandalos nuclear power plant in Spain was running normally when a turbine bearing began overheating. What started as a minor mechanical problem soon escalated into a fire that nearly caused a complete meltdown. The overheated bearing caused the turbine to vibrate violently, rupturing oil lines and spraying flammable fluid everywhere. Within minutes, fire broke out in the turbine hall and began spreading toward the reactor building. The plant's fire suppression systems, designed for normal electrical fires, proved inadequate against the intense blaze fueled by pressurized oil. As flames engulfed critical equipment, the reactor began losing power and cooling capability. Operators scrambled to maintain control as one system after another failed. The fire knocked out electrical power, forcing the plant to rely on emergency diesel generators. When cooling pumps failed, water levels in the reactor began dropping dangerously. For hours, it seemed like the plant might follow the same path as Chernobyl or 3 Mile Island. The real heroes were the plant workers and local firefighters who battled the blaze while radiation alarms screamed around them. They managed to keep the fire from reaching the reactor building and prevented a complete loss of cooling. The reactor was successfully shut down, but the damage was so extensive that the plant never operated again. The accident led to major improvements in fire protection at nuclear power plants worldwide. Investigators found that the fire exposed serious vulnerabilities in reactor safety systems, particularly the risk of common mode failures, where a single event could disable multiple backup systems simultaneously. Moving on to the next tier, we arrive at another disturbing chapter in the history of nuclear accidents. Tier 3. Soviet submarine K-431 reactor explosion, 1985. The K-431 disaster proved that nuclear accidents weren't limited to power plants. They could happen anywhere where atomic reactors operated. On August 10, 1985, the Soviet nuclear submarine K-431 was undergoing routine refueling at Chazma Bay near Vladivostok when a reactor explosion killed 10 sailors and contaminated a vast area of the Pacific Ocean. The submarine was an Echo-class vessel designed to hunt American aircraft carriers during the Cold War. Like many Soviet naval reactors, it had a troubling safety record, but the Navy's obsession with secrecy meant problems were rarely addressed openly. During the refueling operation, workers were removing the reactor's control rods when something went terribly wrong. The explosion was swift and devastating. The reactor compartment was blown apart, launching radioactive debris across the naval facility and into the surrounding waters. Some of the submarine's crew were killed instantly by the blast and radiation, while others suffered severe burns and radiation sickness. The explosion also contaminated rescue workers who rushed to help without proper protective equipment. The Soviet military response was predictably secretive. The area was cordoned off and news of the accident was suppressed for years. Contaminated debris was hastily buried or dumped at sea, creating long-term environmental problems. Many of the sailors and workers involved in the cleanup later developed cancer and other radiation-related illnesses. The workers who risked everything during these events deserve to be remembered, though history has largely overlooked their sacrifices. The K-431 accident was just one of many nuclear incidents involving Soviet submarines during the Cold War. The Soviet Navy's nuclear program was plagued by poor safety standards, inadequate training, and pressure to match American capabilities at any cost. The disaster highlighted the dangers of operating nuclear reactors in military environments where secrecy often trumped safety. What do you think of the ways countries have been handling nuclear materials so far? Leave a comment below and let me know. Ines, Level 4, at Flores, 2006, Belgium. The Flores accident showed how dangerous medical isotope production could be when safety procedures broke down. On March 11, 2006, at the Institute for Radio Elements, IRE, in Flores, Belgium, a worker received a massive radiation dose while trying to fix a stuck source in an industrial irradiator. The accident rated Level 4 on the International Nuclear Event Scale, the same level as the Tokai Mura criticality accident. The facility produced medical isotopes used in cancer treatment and diagnostic procedures around the world. The irradiator used a powerful cobalt-60 source to sterilize medical equipment, and when it jammed, a maintenance worker made a fatal mistake. Instead of following safety procedures, he entered the irradiation chamber while the source was still exposed, receiving a dose of radiation that would ultimately prove lethal. The worker initially seemed fine after the exposure, which made the accident even more tragic. Radiation sickness often has a deceptive pattern. Victims may feel relatively normal for days or weeks before their condition deteriorates rapidly. By the time doctors realized the severity of his exposure, it was too late to save him. He died several weeks later from multiple organ failure. The accident sent shockwaves through the medical isotope industry. Belgium's Nuclear Regulatory Authority launched the major investigation and found serious flaws in the facility's safety procedures and training. The company faced heavy fines and was forced to overhaul its operations completely. The Flores accident highlighted a troubling paradox. Facilities producing materials to save lives were putting their own workers at deadly risk. It also raised questions about the safety culture in the medical isotope industry, where commercial pressures sometimes conflicted with radiation protection. The incident led to stricter international standards for industrial irradiators and better training for workers handling high-activity sources. This next case is a reminder that even standard procedures can lead to serious consequences when things go wrong. Jaslovské Bohunice reactor meltdown, 1977, Czechoslovakia. The Jaslovské Bohunice accident was Eastern Europe's first major nuclear disaster, a reactor meltdown that foreshadowed the later catastrophe at Chernobyl. On February 22, 1977, Unit A1 at the Jaslovské Bohunice nuclear power plant in Czechoslovakia suffered a complete loss of coolant, leading to severe fuel damage and massive contamination of the reactor building. The plant used Soviet-designed reactors that were notorious for their safety problems. During a routine fuel loading operation, operators made a critical error that caused the reactor's cooling system to fail completely. Without coolant, the reactor began overheating rapidly, and fuel elements started melting. The situation quickly spiraled out of control as temperatures soared beyond anything the reactor was designed to handle. Unlike later accidents that made international headlines, Bohunice was kept secret by the communist government. Plant workers and emergency responders worked desperately to contain the damage while radiation levels climbed to dangerous levels throughout the facility. Many of these early responders received radiation doses, though the true extent of their exposure wasn't revealed for years. The reactor building became so contaminated that it had to be sealed permanently. The cleanup took years and involved encasing the damaged reactor in concrete, similar to what would later happen at Chernobyl. Hundreds of workers were involved in the cleanup effort, many of whom suffered long-term health effects from radiation exposure. The accident should have served as a warning about the dangers of Soviet reactor designs, but the culture of secrecy in the Eastern Bloc prevented any meaningful safety improvements. The lessons from Bohunice were ignored, and the same type of reactor flaws that caused the accident continued to plague Soviet nuclear facilities. 9 years later, a similar reactor design would fail catastrophically at Chernobyl, with far more devastating consequences. Honestly, with the number of Soviet nuclear disasters we've gone through, this could have been its own video. Here's another one. The Siberian Plutonium Plant Fire, 1993, Russia. The Tomsk-7 explosion showed that even after the Soviet Union's collapse, Russia's nuclear facilities remained dangerously unsafe. On April 6, 1993, at the Siberian Chemical Combine near Tomsk, a massive explosion rocked a plutonium reprocessing facility, spreading radioactive contamination across the surrounding countryside. The accident happened during Russia's chaotic transition to capitalism, when nuclear safety oversight had completely broken down. The explosion occurred in Building 18, where workers were dissolving irradiated uranium fuel in nitric acid to extract plutonium for nuclear weapons. The process was inherently dangerous, involving highly radioactive materials and corrosive chemicals that could explode if not handled properly. On that April morning, something went wrong during routine operations, causing a violent explosion that blew out windows and scattered radioactive debris for miles. The blast created a radioactive cloud that drifted over nearby villages, contaminating an area larger than some European countries. Local residents had no warning and no protection as invisible contamination settled on their homes, gardens, and livestock. Many people were outside enjoying the spring weather when the accident occurred, unknowingly breathing in radioactive particles. The Russian government's response was chaotic and inadequate. Emergency crews arrived hours after the explosion, and many lacked proper protective equipment. Officials downplayed the severity of the accident, claiming it posed no danger to public health even as radiation monitors registered dangerous levels across the region. The environmental impact of this incident is likely to persist for multiple generations. The Tomsk accident highlighted the parlous state of Russia's nuclear industry in the 1990s. With the Soviet system collapsed but no effective replacement, nuclear facilities operated with minimal oversight and deteriorating safety standards. Workers hadn't been paid in months, equipment was falling apart, and safety procedures were routinely ignored. The explosion served as a stark reminder that nuclear materials remain dangerously volatile, even as the political systems that produced them collapse. This next case underscores Russia's continued prominence as a key player during the Cold War era. Mayak plutonium contamination, various years, USSR. Mayak wasn't just one incident. It was decades of nuclear recklessness that turned a vast area of Russia into one of the most contaminated places on Earth. The Mayak Production Association in the Ural Mountains was the Soviet Union's first plutonium production facility, built in desperate secrecy to match America's nuclear arsenal. From the moment it opened in 1948, Mayak became a source of environmental catastrophe that continues to this day. The contamination began almost immediately with the most cavalier attitude toward radioactive waste imaginable. For years, plant operators simply dumped high-level liquid waste directly into the Techa River, contaminating hundreds of miles of waterway and affecting nearly 500,000 people downstream. Entire villages along the river were secretly relocated as radiation levels soared, but many residents were never told why they had to leave their homes. Then came the 1957 Kishtim explosion, when a waste storage tank blew up and scattered contamination across hundreds of square miles. But even that wasn't the end of Mayak's environmental assault. In the 1960s, Lake Karachay, used as a radioactive waste dump, began drying up during a drought. Wind picked up contaminated sediment from the exposed lakebed and spread it across the countryside, creating yet another wave of contamination. The human cost was staggering. Cancer rates in the region remain elevated decades later, and some areas are still too contaminated for human habitation. The Techa River remains radioactive, and thousands of people continue to live in contaminated areas with limited government support. Mayak represented everything wrong with the Soviet nuclear program: secrecy over safety, weapons production at any cost, and complete disregard for human health. The facility's legacy of contamination will persist for thousands of years, a permanent reminder of what happens when nuclear technology is pursued without adequate safety measures or environmental protection. The Cold War produced many nuclear nightmares, including this terrifying example. Naroda Atomic Power Plant Turbine Fire, 1993, India. The Naroda fire proved that nuclear accidents weren't limited to the superpowers. Developing nations with newer nuclear programs could face the same dangers. On March 31, 1993, Unit 1 at the Naroda Atomic Power Station in Uttar Pradesh, India, experienced a devastating turbine hall fire that came within minutes of causing a reactor meltdown. The accident exposed serious flaws in India's nuclear safety culture and emergency response capabilities. The trouble started when a blade in the main turbine broke loose, causing catastrophic vibrations that ruptured high-pressure oil lines. Within seconds, pressurized oil was spraying everywhere, and the intense heat from damaged equipment ignited the oil into a raging inferno. The fire spread rapidly through the turbine hall, threatening electrical systems that were crucial for reactor safety. As flames engulfed critical equipment, the reactor began losing the ability to cool itself. The fire knocked out the main electrical supply, forcing the plant to rely on backup power systems. But the fire was so intense that it threatened these backup systems too. Plant operators watched in horror as one safety system after another either failed or came under threat from the advancing flames. The real nightmare was the potential for a station blackout, a complete loss of electrical power that would make it impossible to cool the reactor. Without cooling, the reactor would overheat and melt down, potentially releasing massive amounts of radiation. For several terrifying hours, it looked like India might experience its own version of Chernobyl or 3 Mile Island. Heroic efforts by plant workers and local firefighters prevented disaster. They managed to establish alternative cooling and restore some electrical power before the reactor was damaged. The accident led to major improvements in fire protection at nuclear plants worldwide and highlighted the vulnerability of reactor safety systems to seemingly unrelated industrial accidents. I just want to take a moment to thank you for sticking with me. If you're finding this content interesting, consider subscribing to support the channel. It really helps us keep going. San Onofre Reactor Tube Leak, 2012, USA. The San Onofre accident became a modern cautionary tale about nuclear plant maintenance and corporate cover-ups. In January 2012, Unit 3 at the San Onofre Nuclear Generating Station in Southern California was shut down after operators detected radioactive steam leaking from the plant. What seemed like a minor maintenance issue soon evolved into a scandal that permanently closed one of America's largest nuclear facilities. The problem was in the steam generators, massive heat exchangers that had been replaced just 2 years earlier at a cost of $670 million. The new generators, built by Mitsubishi Heavy Industries, were supposed to last decades, but they were already showing signs of serious wear. Thousands of tubes inside the generators were degrading much faster than expected, and some had developed cracks that allowed radioactive water to leak into the steam system. Southern California Edison, the plant's operator, initially downplayed the problem, claiming it was a minor issue that could be quickly fixed. But as inspectors examined the steam generators more closely, they found a nightmare of premature wear and design flaws. The tubes were vibrating against each other, causing unprecedented damage that had never been seen in similar reactors. The Nuclear Regulatory Commission launched a major investigation and found that Edison had made unauthorized design changes to the steam generators without proper safety analysis. The modifications had created flow patterns that caused tubes to wear out rapidly, turning what should have been a routine replacement into a safety crisis. Public pressure mounted as environmental groups and concerned citizens demanded answers. After months of hearings and investigations, Edison made the unprecedented decision to permanently shut down both reactors rather than continue fighting for restart approval. The San Onofre closure became a symbol of how equipment failures and corporate mismanagement could end even a well-established nuclear plant's operations. Now we turn our attention further north, where even Commonwealth nations have their share of controversial history. Chalk River Reactor Meltdown, 1952, Canada. The Chalk River accident was the world's first major reactor meltdown, a pioneering disaster that taught the nuclear industry some of its earliest lessons about what could go wrong. On December 12, 1952, the NRX reactor at Chalk River Laboratories in Ontario suffered a loss of coolant accident that partially melted the reactor core and contaminated the facility with massive amounts of radioactive water. The accident began with a series of operator errors and equipment failures that would become depressingly familiar in later nuclear accidents. During a routine experiment, operators mistakenly opened the wrong valves and pressed the wrong buttons, causing a rapid loss of coolant from the reactor core. As water levels dropped, the uranium fuel began overheating and some of it started to melt. The situation rapidly deteriorated as more systems failed and operators struggled to understand what was happening. In desperation, they tried to flood the reactor with water to cool it down, but this only made things worse by spreading contaminated water throughout the building. The basement of the reactor building filled with millions of gallons of radioactive water that was too dangerous to handle with existing technology. The cleanup was a massive undertaking that drew help from around the world. Hundreds of military personnel, including a young US Navy officer named Jimmy Carter, the future president, were brought in to assist with the dangerous work. Teams could only work for minutes at a time in the highly radioactive environment, and the entire reactor core had to be dismantled and buried as radioactive waste. The Chalk River meltdown provided crucial early insights into reactor safety and accident response. It showed how quickly a reactor could lose coolant, how devastating the consequences could be, and how difficult cleanup operations were. Many of the lessons learned at Chalk River were incorporated into reactor designs and safety procedures worldwide, making it a foundational event in nuclear safety history. The next tier is coming up, and trust me, the stories get even more intense from here. Tier 4. Davis-Besse Reactor Near Breach, 2002, USA. The Davis-Besse nuclear plant in Ohio came terrifyingly close to a catastrophic meltdown in 2002, and we almost didn't hear about it. For years, boric acid had been quietly eating through the reactor's steel pressure vessel head, creating a cavity the size of a football. What's chilling is that only a thin stainless steel liner, about as thick as a soda can, stood between the reactor core and a potential breach that could have rivaled Chernobyl. The Nuclear Regulatory Commission had been pushing inspections back, and First Energy, the plant's operator, had been downplaying corrosion reports. When they finally looked in early 2002, inspectors found a hole so deep you could stick your entire fist into it. The reactor had been running with this massive weakness for months, maybe years. What makes this even more concerning is the fact that similar problems had been identified at other facilities, but Davis-Besse kept getting extensions to delay their inspection. If that liner had failed during operation, radioactive coolant would have sprayed everywhere, potentially leading to a core meltdown. The plant was shut down for 2 years and cost over $600 million to fix. It was pure luck that prevented Ohio from becoming an exclusion zone. This brings us to yet another case where officials prioritize secrecy over safety. Project 57 Radiation Test, 1957, Nevada, USA. Project 57 was one of those Cold War experiments that sounds like science fiction but was horrifyingly real. The military wanted to know what would happen if a nuclear weapon was damaged in an accident. Specifically, would the plutonium create a deadly radioactive mess even without a nuclear explosion? So they decided to find out by blowing up actual nuclear weapons with conventional explosives. In April 1957, at the Nevada test site, they strapped conventional explosives to a nuclear device and detonated it, creating exactly the dirty bomb scenario they were supposedly trying to prevent. Plutonium particles scattered across the desert, contaminating a huge area. The test was supposed to help design safer nuclear weapons, but it ended up demonstrating just how dangerous they could be even when they didn't work as intended. The crazy part? They did this test in the open air with minimal safety precautions. Workers and observers were exposed to plutonium dust, and the contaminated area remained off-limits for decades. The military treated it as just another experiment, but they had essentially created America's first international radiological disaster. Years later, many of the people involved developed cancers, and the site required extensive cleanup efforts that continued into the 21st century. The legacy of atomic recklessness continues with this next chilling case. Soviet K-19 Hiroshima Submarine Incident, 1961. The K-19 submarine incident reads like a nightmare scenario from the depths of the Cold War. This Soviet nuclear submarine, nicknamed Hiroshima by its own crew, suffered a catastrophic reactor coolant leak while patrolling near Greenland in July 1961. The primary cooling system failed, and reactor temperatures began climbing toward meltdown levels that could have triggered a nuclear explosion underwater. Captain Nikolai Zetayev faced an impossible choice: abandon ship and let a nuclear reactor potentially explode in the North Atlantic, or send his men into lethal radiation to attempt repairs. He chose to sacrifice his crew. 8 sailors volunteered for what was essentially a suicide mission, entering the reactor compartment with primitive radiation suits and basic tools to jury-rig a new cooling system. The men worked in shifts, each spending only a few minutes in the reactor room before radiation sickness forced them out. They managed to create a backup cooling system using drinking water pipes, but the damage was done. All 8 men died from acute radiation poisoning within days, and many others suffered long-term health effects. The Soviet military covered up the incident for decades, and these men received no recognition for preventing what could have been an underwater nuclear disaster. Their sacrifice likely prevented radioactive contamination of one of the world's most important fishing grounds. Israeli nuclear waste dumping in the Negev. Israel's nuclear program, centered around the secretive Dimona reactor in the Negev desert, has created decades of environmental contamination that the government has worked hard to keep quiet. Since the 1960s, radioactive waste from plutonium production has been buried in the desert, often with minimal safety precautions that wouldn't meet today's standards for disposing of medical waste, let alone nuclear materials. Former workers at Dimona have reported horrific safety conditions. Radioactive waste buried in shallow pits, contaminated materials scattered around the facility, and workers handling dangerous substances with inadequate protection. Some waste was reportedly dumped in unmarked locations throughout the Negev, creating a scattered pattern of contamination that may never be fully mapped or cleaned up. The health consequences have been severe but largely hidden. Cancer rates in nearby Bedouin communities appeared elevated, and former nuclear workers have reported unusually high rates of cancer and other illnesses. Israeli authorities have been extremely secretive about the extent of contamination, making it difficult for researchers to study the full impact. What's particularly troubling is that much of this waste remains in place, buried in a desert that's increasingly being developed for agriculture and settlements. Unlike other nuclear disasters that happened in moments, this is a slow-motion catastrophe that has been unfolding for over 60 years, with radioactive materials slowly leaching into groundwater and soil that future generations will inherit. The secret Chinese Lopner accident, 1960s to 70s. China's nuclear testing program at Lopner in the remote Xinjiang desert was shrouded in such secrecy that we're still piecing together what went wrong there. What we do know is terrifying. Multiple accidents during the 1960s and 70s that exposed thousands of people to dangerous radiation levels, with the Chinese government covering it up for decades. The worst incidents apparently involved test preparations gone wrong, nuclear devices that leaked radiation before detonation, contaminated equipment scattered across the test site, and workers who had no idea they were being exposed to lethal doses. Former Chinese nuclear scientists who later defected described scenes of chaos, technicians working on nuclear devices without proper protection, radioactive materials transported in regular trucks, and safety protocols that were virtually non-existent. What makes this particularly horrific is the human cost. People living nearby were the ones who suffered most, even though the decisions were made somewhere else. The area around Lopner was home to Uyghur communities who were never warned about the testing. Reports suggest that radiation exposure from both the accidents and the atmospheric tests caused widespread health problems, including dramatically increased cancer rates and birth defects that persisted for generations. The Chinese military treated the entire region as expendable, conducting 45 nuclear tests over 3 decades with little regard for safety or environmental impact. Former workers have reported that accident sites were simply abandoned, leaving contaminated equipment and materials scattered across the desert. Unlike other nuclear powers that eventually acknowledged their mistakes, China has maintained almost complete silence about what happened at Lopner, making it one of the world's most least understood nuclear disasters. Having looked at incidents in China, it's worth turning our attention to Korea. Are nuclear accidents a broader issue across Asia? Alleged Chernobyl-style incident in North Korea. North Korea's nuclear program is so secretive that separating fact from speculation is nearly impossible. But intelligence reports and defector accounts suggest the country has experienced at least one major nuclear accident that was covered up completely. The most persistent rumors center around an incident in the late 1980s or early 1990s at the Yongbyon nuclear complex where something went catastrophically wrong with their research reactor. Defectors have described unusual military activity around Yongbyon, including the sudden evacuation of nearby villages and the deployment of chemical warfare units, the kind of response you'd expect if radioactive contamination was spreading. Satellite imagery from the period shows what appears to be emergency construction and earthwork that could indicate cleanup efforts, but North Korea's information blackout makes verification impossible. What's particularly chilling is that if a major accident did occur, the North Korean government would have had both the motivation and capability to cover it up completely. Unlike the Soviet Union, which eventually had to acknowledge Chernobyl when radiation was detected across Europe, North Korea's isolation means a nuclear disaster could be hidden indefinitely. Intelligence analysts have noted unusual patterns in North Korea's nuclear program that suggest something major went wrong. Delays in reactor construction, changes in personnel, and what appears to be significant modifications to safety systems. Some reports suggest hundreds of people may have been exposed to dangerous radiation levels. But in a country where information is strictly controlled, we may never know the full truth about North Korea's nuclear accidents. This next case demonstrates that nuclear disasters can all be traced back again to the Cold War. Greenland B-52 crash with nuclear payload, 1968, USA. The crash of a B-52 bomber carrying 4 nuclear weapons near Thule Air Base in Greenland is one of those Cold War incidents that sound too insane to be true. In January 1968, a fire broke out on the aircraft during a routine patrol mission. The crew was forced to abandon the plane, which crashed into sea ice carrying 4 hydrogen bombs, each with the explosive power of over 1 million tons of TNT. The impact scattered radioactive plutonium across the ice and snow, creating what the military euphemistically called a broken arrow incident. What followed was a frantic cleanup operation in Arctic conditions, with workers scrambling to collect contaminated ice and debris before the spring thaw could spread radiation into the ocean. The Pentagon sent hundreds of personnel to Greenland where they worked in brutal cold to scrape up contaminated snow and ice. Here's the terrifying part. They only found 3 of the 4 nuclear weapons. For decades, the military insisted all 4 bombs were accounted for, but documents revealed in the 1990s confirmed that 1 weapon was never recovered. It's presumably sitting on the ocean floor somewhere off the Greenland coast, a hydrogen bomb lost in the Arctic waters. The incident exposed the insanity of the Cold War practice of keeping nuclear-armed bombers constantly airborne. These planes flew 24/7 missions carrying live nuclear weapons, and it was only a matter of time before something went wrong. The Thule crash was just the one we know about. There were likely other incidents that remain classified. The culture of nuclear secrecy produced many hidden disasters, including this next one. Palomares hydrogen bomb incident, 1966, Spain. The collision of 2 US military aircraft over the Spanish village of Palomares created one of the most surreal nuclear disasters in history. A B-52 bomber carrying 4 hydrogen bombs collided with a refueling tanker during a routine mid-air refueling operation. The resulting explosion scattered nuclear weapons across a peaceful Mediterranean farming community, turning olive groves and farmland into a radioactive cleanup zone. 2 of the bombs as conventional explosives detonated on impact, spreading plutonium across several square miles of Spanish countryside. Suddenly, this quiet agricultural village was swarming with American military personnel in radiation suits, scraping contaminated soil into barrels while local farmers watched in bewilderment. The images are absolutely surreal. Men in full protective gear working next to Spanish villagers who were initially told there was no danger. The 3rd bomb was found intact, but the 4th had fallen into the Mediterranean Sea, triggering a massive underwater search operation involving submarines, divers, and underwater cameras. It took nearly 3 months to locate the missing hydrogen bomb on the ocean floor, while the world watched and wondered if a nuclear weapon would detonate underwater. The cleanup was a disaster in itself. The US military removed tons of contaminated Spanish soil and shipped it back to America, but they couldn't remove all the plutonium. Parts of Palomares remained contaminated for decades, and some areas are still off-limits today. The incident showed how easily a routine military operation could turn a peaceful village into a nuclear disaster zone, and highlighted the insane risks of flying nuclear weapons around the world during peacetime. The long-term psychological effects on survivors are often overlooked, along with the loss of the lives they once knew. We're getting close to the worst of it. If you've made it this far and you're finding it interesting, a like and subscribe really helps out. Tier 5. Russian submarine K-129 nuclear warhead loss, 1968, Pacific Ocean. The loss of a Soviet submarine K-129 in the Pacific Ocean created one of the most expensive and secretive nuclear disasters in history, one that the American government turned into the ultimate Cold War heist. In March 1968, this nuclear-powered submarine carrying nuclear ballistic missiles mysteriously sank northwest of Hawaii, taking 98 crew members and several nuclear warheads to the ocean floor. What happens next reads like a spy thriller. The US Navy secretly located the wreck 3 miles underwater and launched one of the most audacious covert operations ever attempted. Using a specifically built ship called the Hughes Glomar Explorer, disguised as a deep-sea mining vessel, the CIA tried to secretly raise the entire submarine from the ocean floor to steal Soviet nuclear technology and codes. The operation was partially successful, but also partially catastrophic. The submarine broke apart during the recovery attempt, sending nuclear warheads and radioactive debris cascading back to the ocean floor. The Americans managed to recover part of the sub, along with some crew remains and potentially some nuclear materials, but much of the vessel, including several nuclear warheads, remains on the Pacific seabed. The environmental impact is still unknown. Nuclear warheads and a nuclear reactor are sitting on the ocean floor, slowly corroding in the deep sea environment. The Soviet Union never acknowledged losing the submarine, and the US kept the recovery operation secret for years, meaning that multiple nuclear heads have been sitting on the Pacific Ocean floor for over 50 years with minimal monitoring of their environmental impact. The Karachay Lake Death Zone, Russia. I touched on this briefly in Tier 3, but it's worth digging deeper. Lake Karachay in Russia's Ural Mountains is arguably the most radioactive place on Earth, so contaminated that standing on its shore for just an hour could deliver a lethal dose of radiation. This isn't just post-apocalyptic fiction, it's the result of years of Soviet nuclear waste dumping that turned a once pristine lake into a deadly zone. Between 1951 and 1953, the nearby Mayak nuclear facility dumped high-level radioactive waste directly into the lake. We're talking waste so dangerous it could kill you in minutes, poured into open water like it was a trash can. The lake absorbed more radioactivity than Chernobyl and quickly became a place where wildlife died instantly, and sediment turned into radioactive sludge loaded with strontium-90, cesium-137, and other toxic isotopes. In dry periods during the 1960s, radioactive dust from exposed lakebed spread across surrounding areas, contaminating a region larger than some small countries. Eventually, the Soviets tried to cover it up, literally, by filling the lake with concrete and rocks. But the damage was done. Local residents were left in the dark for decades, and many suffered long-term health effects from exposure. Some of the most damaging nuclear tests didn't happen just in the US or Europe, but actually in remote parts of the developing world, places where the long-term consequences were often overlooked or dismissed. The mysterious Vela incident, 1979, Indian Ocean. On September 22, 1979, an American Vela satellite detected what appeared to be a nuclear explosion in the remote waters of the Indian Ocean, a double flash of light characteristic of an atomic bomb detonation. The problem? No country admitted to testing nuclear weapons that day, creating one of the Cold War's most enduring mysteries and potentially covering up an illegal nuclear test. The satellite data was unmistakable. The signature double flash that occurs when a nuclear weapon explodes, detected over the South Atlantic or Indian Ocean near the Prince Edward Islands. US intelligence agencies scrambled to figure out who had detonated a nuclear bomb in secret. The leading theory pointed to a joint Israeli-South African nuclear test, both countries that had nuclear capabilities but weren't supposed to be testing weapons. What makes this incident so disturbing is the cover-up that followed. The Carter administration, not wanting to deal with the diplomatic fallout of confirming an illegal nuclear test, quietly suppressed the findings. A hastily convened panel of scientists suggested the satellite might have malfunctioned, but their conclusions were widely criticized as politically motivated rather than scientifically sound. Years later, evidence continued to mount that the Vela satellite had indeed detected a real nuclear explosion. Radioactive fallout was reportedly detected in Australia, and intelligence sources suggested that Israel and South Africa had collaborated on nuclear weapons development. But the official line remained that nothing had happened, leaving one of the most significant nuclear incidents of the Cold War shrouded in deliberate ambiguity. If a nuclear weapon was detonated that day, it represents a successful international conspiracy to hide an illegal atomic test. Tier 6. The Broken Arrow incidents that were never recovered. The US military's Broken Arrow classification covers accidents involving nuclear weapons, and while most incidents were eventually resolved, several nuclear weapons remain missing, lost somewhere in the American landscape or ocean floors, ticking time bombs that could theoretically still detonate or leak radiation. I had talked earlier in Tier 4 about the Greenland B-52 crash, but there were actually more devastating incidents like them. The most famous is probably the hydrogen bomb lost off the coast of Georgia in 1958. During a training mission, a B-47 bomber carrying a nuclear weapon collided with an F-86 fighter jet. The bomber crew, struggling to maintain control, jettisoned the nuclear weapon into Wassaw Sound near Tybee Island before making an emergency landing. Despite extensive research efforts, the bomb was never found and remains somewhere in the coastal waters off Savannah. Another nightmare scenario involves a nuclear weapon lost in the swamplands of North Carolina in 1961. A B-52 broke apart in flight, dropping 2 nuclear bombs near Goldsboro. One was recovered, but the other buried itself so deep in waterlogged farmland that recovery was deemed impossible. The military bought the land and restricted access, but the weapon remains buried somewhere beneath a North Carolina field. There are other incidents that remain classified, but defense analysts estimate that several nuclear weapons are still unaccounted for from Cold War incidents. Some may have been lost at sea. Others buried in remote locations, and a few might be in populated areas where their exact location was never pinpointed. These weapons represent a long-term environmental and security risk, aging nuclear materials that could potentially leak radiation or, in worst-case scenarios, be recovered by hostile actors decades after they were lost. And now for the final act for this video. The Manhattan Project and its nuclear disaster legacy, USA. While the Manhattan Project is often seen as a scientific breakthrough that helped end World War II, it also created one of the earliest and most enduring nuclear disasters in American history. The urgent push to develop atomic weapons came at a severe cost: environmental contamination, secrecy, and human suffering. Sites like Hanford, Washington, Oak Ridge, Tennessee, and Los Alamos, New Mexico, processed uranium and plutonium under tight deadlines with minimal safety measures. At Hanford, massive amounts of radioactive waste were released into the environment, polluting rivers and soil. These facilities were designed for war, not for protecting public health or the environment. The project also involved secret human radiation experiments in the 1940s, where unsuspecting patients were injected with plutonium and uranium. These tests were only revealed decades later, raising serious ethical concerns. The fallout of the Manhattan Project is still felt today: leaking waste tanks, contaminated land, and water near former production sites pose ongoing hazards. Surrounding communities report higher rates of cancer and illness, often without adequate recognition or support. Ultimately, the Manhattan Project didn't just produce the atomic bomb, it initiated a nuclear disaster with environmental and human costs that the US continues to confront more than 80 years later. If you enjoyed the video, make sure to hit subscribe with notifications turned on and check out my last video, The Torture Methods Iceberg.